Now we're going to start our exercise 13.3. Check question number 6. What is given in this question? I'm going to read question. How many silver coins 1.7 centimeter in diameter and the thickness of the coin is 2 millimeter must be melted to form a cuboid dimension 5.5 centimeter and 10 centimeter into 3.5 centimeter. So in this question, we want to find the number of coins. With the help of this coin, I want to make this cuboid. So dimension of coin is given, diameter 1.7 centimeter. So half of diameter is going to be radius. So I want to divide diameter by 2. After I want to remove this decimal, so I take 100 downwards. So this is going to be 7 by 8 centimeter. So this is the radius of the coin. Now the thickness of the coin is given. What do you mean by thickness? See, this is your coin. So this is the coin. So this is the thickness. So this thickness is given. The thickness of the coin is given 2 mm. So in this question, we're going to check how many coins are required. How many coins are required? With these coins, I want to make this cuboid shape. Okay, with the help of these coins, I want to make this cuboid shape. So how many coins are required to make this shape of cuboid? So this is your question. So in this question, we want to find the number of coins so that this solid is possible to make. Okay, now what is given? Height of the coin is given 2 mm. So in 2 millimeter, 1 centimeter, in 1 centimeter, 10 mm is there. So I want to convert in centimeter. So I want to divide it 10. 2 1 are 2, 2 5 are 10. So height of the coin become 1.5 centimeter. Now who will tell what is the shape of coin? My question is, what is the shape of coin? Okay, if you know the answer, raise your hand. I want to ask one by one. What is the shape of the coin? My question is, tell the shape of coin. Okay, I got answer from Nave. Right, beta? Now I want to ask from some students. Yes, Taranjot, open your mic, beta. Taranjot from 10th Florence. No. Just Taran, beta, sit on your seat. Yes. Aditya Jain. So today I want to ask from Aditya Jain. Aditya Jain, open your mic, beta.
Good morning, sir.
Good morning. Tell beta, what is the shape of the coin?
Cylinder.
Yes, cylindrical. Because when we take so many coins, see, this is the one coin. I take 3-4 coins. Now, what is the shape of this coins? This is going to be cylindrical. So coin shape of the coin is in the cylinder. So this is going to be cylinder. When we put more coins, it is going to rise one by one. So the shape of coin is going to be the cylinder. Now the height of cylinder is given and the diameter of cylinder is given. This, with the help of these coins, I want to make this solid. So this is the shape of cubidical. So I want to find the volume of cuboid LBH. Which means I required number of coins. So I write here number of coins is equal to total volume of the solid going to divide with the volume of one coin. If I'm going to divide this volume by the volume of one coin, so total number of coins are there. So formula become number of coins equal to volume of the cuboid. Volume of the cuboid upon volume of one coin. Volume of the one coin. So now coin is the shape of cylindrical and this shape is cubidical. Okay. So if we're going to divide volume of this solid with the volume of one coin, the number of coins are there. Now you know this shape is cubidical. So how are we going to find the volume of this cuboid? So formula is L into B into H. Now this coin is in the shape of cylindrical. So how are we going to find the volume of cylinder? So formula is pi r square H. So use formula pi r square H. Okay. Now what is length? 5.5. So right here 5.5. What is breadth? 10 centimeter. Right here 10 centimeter. What is height? Height is given 3.5. So right here 3.5. After that, value of pi not given, to use 22 by 7. After that, r square. What is the radius? Radius of the coin is 7 by 8 centimeter. So I want to use this value 7 by 8. So I write here 7 by 8 into 7 by 8 into height. Height of the coin. Height of the coin is 1 by 5 centimeter. So use this height. I write 1 by 5. Okay, now I want to solve this. I take this all values which going to lie in the denominator towards the numerator first. I take 7, 8, and 5 towards the numerator. So I write again 5.5, 10, 3.5. I take 7, 8, and 5 towards the numerator. This is going to be 7, 8, and 5. Now what is left? 22 into 7 into 7. I want to remove this decimal. To remove this decimal, I want to write 10. I also want to remove this decimal. To remove this decimal, I want to write 10. Now I'm going to cancel one by one. See, 11 2 is 22, 11 5 is 55. Clear? This 7 going to cancel with 7. Now this 10 going to cancel with 10. And this 7 1 is 7, 7 5 is 35. Now what left? This is going to be 2 4 is 8. Okay? Now 10 is also there to cancel this 10 also. 5 1 is 5, 5 2 is 10. And this is going to be 2 2 is 4. Now what left? 5 into 5 into 16. It means 25 into 16. 25 into 16 going to be 400. It means number of coins equal to 400. If 400 coins are available, with the help of 400 coins, I am able to make this shape of the solid. I hope it is clear now. If doubt is there, then send message on my chat box. Vanshika, 10th Blossom. Open your mic, beta. Vanshika,
Yes,
from
sir.
10th Blossom. Is it clear, beta?
Yes, sir.
Okay, beta. Thank
Yes,
you.
sir.
Okay. Now I want to ask from Devinder Kaur. Devinder Kaur from 10th Blossom. Devinder, open your mic,
Yes, sir. Yes, sir.
Is it clear?
Good afternoon. Yes, sir.
Okay, beta. Thank you. Harinder sir, good afternoon.
Good afternoon, Joginder sir.
How are you, sir?
Good, sir.
Okay. You want to
Sukhman,
ask something, sir?
Vineet, Divya Sandhu, Yashmeet, Garv, Ekam, Kamalpreet, Priyank, Bhushan, Dhruv. Switch on your cameras, boys and girls. Continue, sir. Continue.
Okay, sir. Now check question number 7, beta. Check statement of question number 7. Now in question number 7, what is given? A cylindrical bucket of height 32 centimeter and the radius is given 18 centimeter is filled with the sand. Now I want to solve question number 7, beta. Now in this question, one cylindrical bucket is there. This cylindrical bucket is full of sand. Okay, so sand is there. This is full of sand. Now the dimension of this bucket is given. Height is given 32 centimeter. And the radius of this bucket is also given 18 centimeter. Now in next, this bucket is emptied on the ground. Now this bucket I want to empty on the ground. So this is your ground level. I want to empty this sand on the ground. When we want to empty this sand from this cylinder on the ground, now the shape going to be made of this sand going to be conical. It is given. Read your question. This bucket is emptied on the ground and the conical heap of sand is formed. So this is the conical heap of the sand. Now sand going to be take another shape. Now this sand going to be takes shape of conical. So this is the conical heap of the sand. And the height of this conical heap is given. So height of this conical heap is given 24 centimeter. So right here 24 centimeter. So in this question, we're going to find the radius and the slant height of the heap. It means in this question, we're going to find the radius. So this is the radius and this is the slant height. So R and the L of this conical heap we're going to find. Okay. Now check this question. whatever sand is in the bucket, I use this sand here. It means volume of both the sands are going to be equal to each other. Here it is in the shape of cylindrical, and in the second part it is in shape of the conical. So I write here volume of the cylinder is equal to volume of the cone. Okay, because both sands are going to be equal to each other. The amount of sand are going to be equal to each other. It means volume of sand going to remain same. Here shape is different, here shape is different. So I use volume of cylinder equal to volume of cone. Now you know formula finding the volume of cylinder. Formula is pi r square h. So I use capital R and capital H in the cylinder. So I write here pi capital R square h. And the volume of cone you also know 1/3 pi r square h. Okay. Now this pi going to cancel with pi. Now radius and height of this cylindrical portion is given. What is the height and radius? Radius is 18 and the height is 32. Use here. So 18 is radius is 18. So I write here 18 into 18. Height of cylinder is given 32. So write here 32 equal to 1/3. Radius of this conical portion is not given. Radius of this conical heap is not given. We're going to find the radius and the slant height of this conical heap. So R going to remain same. So R square going to remain same. Height of the conical heap is given 24 centimeters. So I use this height here. So I write here 24. Now 3 1s are 3, 3 8s are 24. Now what is left? So I left R square into 8 equal to 18 into 18 into 32. In this question, we're going to find the value of R, means radius. So take this 8 from left to right. When you're going to take this left to right, this 8 going to divide this portion. So this can be written as R square 18 into 18 into 32 upon 8. Now 8 1s are 8, 8 4s are 32. Okay. Now this 4 can be written as 18 into 18. This 4 can be written as 2 into 2. Can I write 4, 2 into 2? Now 18 to the 36 and 18 to the 36. It means it's going to be a square of 36. Okay. 18 and 18, 2 times 18 are already there. Now what left? 4 left. I want to write 4, 2 into 2. It means 18 to the 36 and 18 to the 36. So this is going to be the square of 36. It means R square is equal to square of 36. Now cancel this square with square. What is left? So radius is left. So radius is going to be 36 centimeters. So this is the radius of the heap. Conical heap having radius 36 centimeters. Now we're going to find the length, slant height of the conical heap. Now who will tell? I want to find the slant height of the conical heap. My question is, I want to find the length of the slant height of the conical heap. So Simran is there. Simran from 10th Hosam, open your mic.
Good afternoon, sir.
Yes, Simran. Tell, I want to find the slant height of the cone. Tell
Sir,
formula.
root
Okay, square root
R square
R square,
minus H square.
not minus, beta, it is plus. R square plus H square is there. Minus is not there, beta. Okay.
Okay, sir.
So finding the slant height of the cone formula is R square plus H square. Now what is R? R is 36.
Yes.
Yeah. So right here 36 square. What is the height of the cone? 24.
24.
So right here 24. And it's square. Now square of 36. Square of 36 is what? Yes, 1296. And the
Yes.
square of 34 is 576.
Yes, sir.
Now add these two terms and tell what value is there.
1872.
1872 beta.
Yes, sir.
Now make the factor of 1872. It's going to be 12 into 12 into 30. When you're going to make the factor of this 1872, the factor going to be 12 into 12 into 30. Now this pair is going to complete it.
Yes, sir.
So this pair is going to complete it. So this 12 come out and 13
Yes.
going to remain inside
12
the
root.
square root. So length of the plant height or length of the cone going to be 12 root 13 centimeters. Right there, centimeters. I hope it is clear to everyone.
Yes, sir.
Send message to me, beta, if it is clear. If any doubt is there. Okay, Sneha, send message clear, sir. Okay, beta. Lavanya, yes, sir. Aditya, 10th Blossom, clear, sir. Okay, Akshara, Priya, send message to me. Okay, beta. I hope it is clear to everyone. Harshita, beta, be attentive in your class. You are drinking tea during class. Okay. Now check next question, question number 8. So this question number 8 is very important. Check carefully. Now check statement. This question is very important, beta. Okay. Some imagination is there. Okay. You are going to imagine the figure of this question. Now read the question carefully. What is given? I'm going to solve this question number 8. So water in a canal 6 meter wide and 1.5 meter deep is flowing with the speed of 10 kilometer per hour. Now, how many area will irrigate in 30 minutes if 8 centimeters of standing water is needed? Read this question again. Water in the canal. Some water is going to be flow in the canal. Width of the canal is given 6 meter and the height, deep means height of the canal is given 1.5 meter. And this water going to be flow in the speed of 10 kilometer per hour. How many area will it irrigate in 30 minutes? We're going to open the water of the flow towards the field. Okay. So question is, in 30 minutes, how much area is going to be irrigate if 8 centimeter standing water is required? In the field, we're going to stand 8 centimeter water. Okay. Now, see on the board. First, who will tell? What is the shape of canal? My question is, what is the shape of the canal? If you imagine right, so then raise your hand, beta. Okay, Kunal is there. He raised his hand. I want to ask from Kunal first. Where is Kunal? Kunal, open your video, beta, first. If your video is open, then you are visible to me. Open your video. Where is going Kunal? Yes. Kunal, you are not visible in your video. First, check your camera. Show your face in camera, beta. If you are visible in camera, then I want to ask a question from you. Otherwise, I want to send you in waiting room, beta. Open your camera, otherwise I want to send you in waiting room. Okay, you are not going to listen. It means put in waiting room. So I put in waiting room. Now Kunal is moved towards waiting room. Now Aditya Jain, open your video, beta. Aditya Jain, you are not visible in your video. Yes, now you are visible. Open your mic, beta.
Yes, sir.
Yes. What is the shape of canal? Tell first.
Cylindrical.
No, beta, it is not cylindrical. Okay. Now I want to ask from Simran. Simran, open your mic.
Yes, sir.
First, open your yes. Tell what is the shape of canal?
Cuboidal.
Okay, cubical. Okay, this is the right answer. Okay. Now the shape of canal is in the shape of cubical. So suppose this one is your canal. Okay. So this water going to be flow in the canal. So this is your water which going to be flow in the canal. Now some field is there. Suppose this one is your field. Okay. So in this field you're going to open this water. We're going to open this water for 30 minutes. For 30 minutes, I want to open the flow of this water towards the field so that there is water in the field. So question is, if 8 centimeter water is required in this field, it means height of the What is given? 8 centimeter. So this is the height of the water in the field. It is given. Now question is how many area it going to be irrigated in 30 minutes. Now what is given? The width of the canal is given, means breadth of the canal is given, which is 6 meter. Depth of the canal means height of the canal is given, which is 1.5 meter. And the speed of this water, is given, which is 10 kilometer per hour. Right here 10 kilometer per hour. Okay, I hope this figure is clear to everyone. This is your canal. In your canal, this water is going to be flow, and the speed of water is given 10 kilometer per hour. We are going to open the flow of this canal towards the field. Okay, towards the field for 30 minutes. It is given, time is given. We are going to open the flow of this water for 30 minutes so that water going to be in the field. So water going to be standing 8 centimeters. So we are going to stand water 8 centimeters. It means height of the cubitical shape is going to be 8 centimeters. We're going to check how much money area is going to be irrigated. Okay, so it means volume of water flow in 30 minutes is going to be equal to the volume of water in the field. So write first volume of the water. Volume of the water flow in 30 minutes is equal to volume of the water in the field. Okay, so water is going to be whatever water is going to be held by this field, it's going to be equal to volume of water flow in 30 minutes. In 30 minutes, whatever water is going to flow, volume of that water is going to be equal to volume of water in the field. I hope this step is clear to everyone. Now your canal is also shape of cubitical, and this area of field is also cubitical. Okay, this shape of field is also cubitical. I want to find the area of field. So formula is L into B into H. Since this field is also cubitical, the formula going to remain same, L into B into H. I use capital LPH towards the canal and small LPH in the field. Okay. Now in this, what is the question? In your question, you are going to find the area of the field. I required area of the field. Now who will tell? I want to find the area of this shape. This is the shape of rectangle. I want to find the area of this rectangle. So formula is L into B. It means L into B I required. So finding the area of this field, L into B is required. It means I want to leave this L into B. So instead of L into B, can I write area of field? If I want to multiply area of field with the height equal to the volume of the field. Okay. So instead of L into B, I write area of the field into height. Height is given 8 centimeter. Now check what is given. Breadth is given 6 meter. Height is given 1.5 meter, and it's going to go for the 30 minutes. Length is missing. In the cubitical shape of canal, length is missing. Now who will tell how to find the length of this canal? So my question is, how to find the length of this canal? The water which is going to flow in the field, so that length is required, beta. In this question, I want to find the length of the canal of the. Yes, Akshara, open your mic, beta. Akshara.
Yes, sir. Good morning.
So
Good
I want to
afternoon,
find the length
sir.
of the canal.
Sir, by formula of speed,
What formula are you going to use? Tell.
d by t, distance upon time.
So distance is given, beta. So distance is going to be the length, beta.
Yes, sir. Distance.
But
Yeah.
distance is not given. So distance I am going to find now. So distance is going to be length.
Yes,
So
sir.
which is not given. Okay. Now check on the board. Speed is given now. What is the speed of
Yes,
the
sir.
water? What is the speed of the water?
10 kilometer per hour.
Okay. So I write here in 60 minutes. Water flow. In 60 minutes, water flow equal to 10 kilometers. In 1 kilometer, 1,000 meters there. So I'm going to write here 10,000 meters. Is it okay? Instead of 10 kilometers, I write 10,000 meters. Now
Okay.
in 1 minute, water going to be flow 10,000 upon 60. Now I want to open the flow of water for 30 minutes. In your question it is given. We're going to open the flow of water for 30 minutes. So I want to write here in 30 minutes water flow equal to 30. Okay, I want to multiply it by 30. Now 31 is 30, 32 is 60. So we are going to cancel. So this 5,000 is there. So it means 5,000 is going to be the length of the canal. Length of the canal means this. Suppose this is the length of 5,000. It means this much water is going to be flow out in 30 minutes. Length of the canal is going to be larger than 5,000. It's going to be more than 5,000. It means from this end to this end. If I suppose from this end to this end going to be 5,000 meter, it means that water is going to be flow out in the 30 minutes in the field. I hope it is clear now. So
Yes,
length of
sir.
the canal becomes 5,000. Is it clear, beta?
Yes, sir.
Okay. Now all terms are in the meter, but it is in centimeter. I want to move in the meter. So how it is possible? If I divide it by 100. Now 4 2s are 8, 4 2s are 8, 4 5s are 20. So this is going to be 2 by 25 meter. Now height of the field become in meter. Okay, beta? So I write here 2 upon 25. Now length of the canal become 5,000. So write here 5,000. Into breadth is given 6 meter. So write here 6 meter. Height is given 1.5. So write here 1.5 meter. Okay. So remove this decimal. So 10 is there. I want to take this 2 by 25 from right to left. So this is going to be reciprocal. So what is left here? Only area of field. So I write here area of the field. Area of the field is equal to, I write this value first, 5,000 into 6 into 15 upon 10. I take this value 2 by 25 from right to left. This is going to be reciprocal. So reciprocal of 2 by 25 going to be 25 by 2. Okay. Now cancel 1 by 1. 0 going to cancel with 0. Now this is going to cancel with 3. 2 3s are 6. Now what is there? 3 5s are 15. 15 into 15, 225. 225, I'm going to multiply 25. Which answer is there? 3 5s are 15. 15 to 15 going to be 225. When going to multiply 225 by 25. So answer becomes 5625. So right here 5625 and 20 left. So write 20 also. So it's going to be meter square. So this is the area of the field which going to be irrigated in 30 minutes. I hope it is clear to everyone now. If any doubt is there, send message. Otherwise, I'm going to start next question. Now, Akshay, is it clear now? Akshay, open your mic again.
Yes, sir. Clear.
Okay, beta. Koshima send message. Clear. Lavanya, no doubt. Okay, beta, no doubt. Vanshika also send message. Okay. So, I hope it is clear to everyone. Now, we're going to start with next question, question number 9. Okay. So, today we're going to complete this exercise and this chapter also. Okay. So, revise all the exercise 13.1, 13.2, 13.2 day and bring your doubts on Monday. So, Monday is your doubt session. Okay. After taking your doubt session on Tuesday, I'm going to take the test of this chapter. So, test of this chapter is going to be, I will take test of this chapter on Tuesday. On Monday, I will take your doubt session. So revise this complete chapter today. If doubts are there, you're going to ask that doubt on Monday. Okay. I hope it is clear to everyone now. So Monday, I'm going to take your doubt session to take your doubts from exercise 13.1, 13.2, 13.3. 13.4 is not in your syllabus. So cut your 13.4 exercise. So this is the last exercise. Now we're going to solve last question of this chapter, question number 9. Read this question again. This is going to be the same question, but in this question I use cubical shape. In the next question I am going to use cylindrical shape. Now check last question, question number 9. Question number 9. Read the statement of this question first. A farmer connect a pipe of internal diameter of 20 centimeter from a canal into a cylindrical tank of her field, which is 10 meter in diameter and 2 meter in deep. Okay, again canal is there. Suppose this one is your canal and water flowing in this canal in this way. Now what you going to do? You take one pipe and connect this pipe in the canal, and water start moving from this canal towards this pipe. Now when you water is going to moving start from this pipe, so you put one large tank under this pipe so that this water going to be hold in the cylindrical tank. Okay, so this is your figure of this question. Now read this question again. A farmer connect a pipe. This pipe going to connect in the canal. So this pipe is given. Okay. Now the dimension of pipe is given. What is the diameter of this pipe? 20 centimeter. If diameter is 20 centimeter, the radius become 10 centimeter. Okay. Now this pipe is going to be, now water start moving from this pipe, and this water is going to store in another cylindrical tank. The dimension of this tank is also given. So diameter of this tank is given 10 meter. If diameter is 10 meter, the radius become 10 upon 2 equal to 5 meter. Okay. And the height of this tank and the deep or height both are going to be equal. It's going to be 2 meter. Radius and height of this tank is given. Radius is 5 meter and the height of this tank is 2 meter. Now question is, if water flow from the pipe at the rate of 3 kilometer and the speed of this water is again given. Speed of water is 3 kilometer per hour. So right here 3 kilometer per hour. Now water this moving out now from the pipe. The speed of water is given 3 kilometer per hour. Okay. So question is, in how many time will the tank be filled? How many time this tank going to fill with the help of this pipe? So I am going to find the time. So I want to find the time. So time is not given. So I suppose let this figure is clear to everyone. Better tell first. This figure is clear to everyone. Tanishka Sharma, 10th Osam, open your mic. Tell fast, beta. Only 3 minutes left. Open your mic.
Good afternoon, sir.
Good afternoon. This shape is clear, beta. This figure clear to you?
Yes, sir.
Okay, beta. Now I want to complete this question. So now water is going to be moving out from this pipe, and we are going to find the time. So I suppose let in X minute. Let in X minute tank will be filled. Let the in X minute this tank going to be filled. Okay, this large tank going to filled in X minute. I suppose the time taken by water to fill this tank to be X meter. This pipe take X minute to fill this tank. Okay, so I suppose the time taken by this pipe be X minute. In the X minute it's going to be fill the tank. Okay, let the time taken by the pipe to fill this tank be X minute. Now speed is given. So 3 kilometer per hour means in 1 hour it's going to be our 3 kilometer. 3 kilometer or 3000 meters. So I write here in 60 minutes water flow equal to 3000 meter. In 3 kilometer 3000 meters there. In 1 minute it's going to be flow 3000 upon 60, and I suppose let the time taken by be X minute. So I write here in X minute it's going to be 3000 upon 60 into X. Now this 0 going to cancel with 0. So this is going to be 3 5 50.